Okay, so let us look at the second operation, which is intersection of sets. Now, intersection of roads, does that mean anything? It's just a crossing. If I look at two roads, they are intersecting or they are crossing. So intersection simply means what is common. So if I look at this, this is the part area. So in the perspective of sets, it is useful to know intersection of set means simply finding out the common elements of the sets under consideration. That's what intersection is all about. Now let us look at the mathematical definition. So intersection of sets, this is the symbol, an inverted U. Uh, A intersection B. So for two sets A and B, A intersection B is defined as all those elements, the set containing all those elements X, right, which is the general form of that representation where X belongs to A and X belongs to B, right? Which means we are just picking out the common elements in both the sets under consideration. And please note, when we say intersection of sets, we are, just for the sake of simplicity, we are taking two sets, but then it applies, this operation could apply to more than two sets as well. In that case, we would just end up finding out how many common elements are there in all the sets that we are considering. Now let us look at the intersection operation using a Venn diagram. Now we just saw that A intersection B is represented as all those elements X where X belongs to A and X belongs to B. That is, it consists of the elements belonging to both the sets under consideration. Now here is what we have: a Venn diagram where U is the universal set, A is the set denoted by the red circle, B set denoted by the orange circle. Now what is the portion that is common between A and B? Intersection, right, as the name suggests, and which is pretty obvious here. This part is common. So this is all the elements that fall in this area over here would be the A, the set that has A intersection B, right? It's a new set containing of elements that are common both to A and B. Now let us look at an example. So we have the set A comprising of numbers from 1, 2, 3 all the way till 10, that is the first 10 natural numbers, and then we have the set B which has the even numbers from 1 to 10, that is we have 2, 4, 6, 8 and 10. What is A intersection B? Now in this case, if you look at it, the common elements between set A and set B, so I think it might be helpful if we could just write down the set A in a bit in its entire form. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Now all we have to do is to identify the elements that are common. So let's start with 2. We have 2 over here, 4, 4, we have 6 in B, 6 in A, 8 in B, 8 in A, 10 in B and 10 in A. So all the elements that are common to A and B is represented by A intersection B, and therefore the A intersection B is represented by 2, 4, 6, 8 and 10. Now interestingly, you would see that A intersection B is nothing but the set B over here. Now if we try to generalize this observation, let me use a different color. So we see that B is a subset of A. Okay, now for this situation we are observing that A intersection B equals B. Okay, so when you have one element as a subset of one set is a subset of another one, and when you try to take the intersection, it is always equal to the subset. The result is always equal to the subset. Okay, now let us look at the properties of intersection of sets like we did for the union. Now again, A intersection B, so and B intersection A, that is, it doesn't matter in which order you are considering to find out the common elements, right? So if you were to uh, find out what elements are common between A and B in one order, so that is, you look at the elements of A first and then you compare them with B, or you look at the set B and then find out what elements are common in A. Doesn't matter, you'll still get the same result. So that is what the commutative law is. Now associative law is, how do you group this operation of intersection? So let's say that you have three sets, A, B and C, and you are supposed to take the common elements between all those three. So you would just decide that, okay, I'm first going to find out the common elements between A and B, and in that case you would do this operation first, A intersection B, and then the resulting set, right? Then you proceed to find out the common elements between this set, that is, once you did the A intersection B, and then find out common elements with C. So you get one result there. Or what you would do is you would say, oh no, I would just like to do the B intersection C first. I would like to find out the common elements between B and C, because maybe these are smaller sets and it's very easy for me to do that. So you would just find that out, and then you would use this result and find out what are the difference elements between A and this new set that has been formed by taking the common elements. For both the cases, that is, whether you consider the left hand side here and the right hand side, you will get the same result, right? So it doesn't matter the grouping, the grouping doesn't matter, you will still get the same result. Then we also have the law of phi, that is, A intersection phi equals phi. Well, what is common with phi? Nothing, right? What is common with an empty set? Nothing could be common with an empty set. Therefore, the result is always going to be an empty set. U intersection A is A, and this kind of follows from the rule that we saw earlier, that if you are trying to find out common elements between a set that is a subset of a bigger set, the result is always a subset. Since A is a subset of universal set, so in this case we have U intersection A to be equal to A. Also, A intersection A is always equal to A, right? So what is common between A and A? All the elements of A are common between itself, and therefore you get this as A. Pretty intuitive. Now let's look at another operation, that is distributivity, and this is where we are combining the union with intersection. Now remember, union means combine and intersection means common. So let's say that we have to find out the common elements, okay, between A and the union of B and C. That is, you need to combine two sets and then find out what is common between that new combined set and another set A. So you could do this A intersection B union C. So you can find out your result that way. Now this could also be arrived in a different way. What you could do is, you may say, okay, I'll just find out what is common between A and B, what is common between A and C, right? I'll just find out those elements, and then all I'll do is I'll take a union of those. I'll combine those elements. In both the cases, we get the same result. So this is known as the distributive law. So that's pretty much it, and this law will definitely be helpful when we do some of the problems later on. So worthwhile to understand how it works intuitively.